This video will demonstrate using WAGO's 750-636 DC drive module over Ethernet IP on remote I/O. We're going to start with a 750-352 coupler. We'll add a 750-602 24 volts DC power module to the system. Next we'll add our DC drive module. This is a 750-636 capable of 5 amps at 24 volts PWM control over the motor. And we'll close the node with a 750-600 end module. For test purposes, we'll be using an Allen Bradley L16ER CompactLogix processor. And for our motor hardware, we're going to be using a small 24 volts DC motor with integrated encoder. The encoder on this motor is 5 volts, so we'll use a WAGO 24 volts to 5 volts DC converter as well. Once this is wired up, we're going to then move to the settings on the coupler itself. We're going to start by setting the IP address and enabling the Ethernet port. So we'll open Ethernet settings. If you don't have this, there's a link to download it in the description of this video. We're going to select the WAGO USB service cable and look at the settings of the coupler. Now there's no IP address set here, so we're going to change the settings to static IP, and we're going to set an IP address compatible with our system. Next we're going to move over to protocol. We're going to disable the Modbus TCP and UDP ports. We're going to enable the Ethernet IP and write those settings to the coupler. We'll create a new project in RSLogix and call it WAGO DC Drive. Select our controller and begin. Now the first thing we'll do is we're going to add a new Ethernet device to the network. Right-click Ethernet, new module, generic device, and then we'll name our system. We're going to call ours WAGO RIO, and we're going to change the data type to SINT. We'll add the IP address, and then here we'll take a look at the process image real quick and notice that we have 6 bytes of data in and 6 bytes data out. We'll need that for the mapping. Add assembly instance 107 with 6 bytes and 101 with 6 bytes. Next we're going to add our add-on instruction to our project. We're going to import that by right-clicking add-on instruction and selecting import. As you can see, WAGO has a nice broad offering of add-on instructions. These are all available by request. Click the add-on instruction, the .l5x file that you like, and click import, and it will bring all the contents of that add-on in. So we're going to go into our main routine now and use the function block out of that add-on. We're going to start by creating 2 rungs with copy functions, and in between those we're going to add our function block from our WAGO_636 add-on instruction. We're going to enter tag names for each of the variables in the function block, and once we've entered a value in each of these, we're going to just right-click on each one and select New to add them to our program tag table. Next we need to copy the data into and out of the block. So we're going to start with our first copy function block. We're going to copy the data starting at WAGO RIO data 0. We're going to copy that into my in data, which is our input data for the block, and we're going to copy 6 bytes. We're going to do this in reverse for the output data as well. We're going to start with out data, my out data 0. We're going to copy that into WAGO RIO out data 0 and 6 bytes as well. Next we're going to just add 4 rungs to this project for test purposes, all just simple coils and contacts. We're going to create 4 new contacts, and we're going to tie those respectively to enable, preset, optimize, and go. This is going to allow us to control our motor over the bus. So once we've done that, we're going to go ahead and download the project to the controller. And we're going to put the controller into run mode. Once finished downloading, we can monitor the outputs of the function block as well as control the inputs. So we're going to go ahead and enable the motor by cycling the first contact. And we're going to put a value in here of 100. We're going to go ahead and preset that into the encoder value of the motor. So once we see that works, we're going to go ahead and turn optimize on, and we are going to put a value of 1000. For the position, for the target position, we're going to enable the motor, and you can see that it goes to position quite quickly. Now we're going to change that value. We're going to put it back to 0, enable that, and run this back to 0. So you can see we're within 1 count of the target position. We can leave the go enabled and run to any position that we feed it, and you can see that it works quite quickly and it's very snappy. Thank you very much for watching this video.